Hey there, my name is Michael Salati, and welcome to the first video in a series dedicated to algorithm design and analysis, otherwise known as the bane of every undergrad's computer science degree. Today we're going to be starting the series by looking at a sorting algorithm for arrays called an insertion sort. So, let's just jump into it. Okay, so over here we have an array of unsorted numbers 6, 5, 3, 1, 8, 7, 2, 4. And we're going to implement the insertion sort function just like this. So we're creating our function called insertion sort, and it is going to take an argument of an unsorted array. And that unsorted array is just going to be an array of numbers. Now, eventually this function is going to take the array and sort it. So we're going to create a placeholder for that sorted array, and we'll call it sorted array if I can type correctly. Hold on one second. And some logic will take place that'll sort the array into sorted array and then return that sorted array. And we're just going to add a little bit of JS doc here so we can document that the typing that the insertion sort is going to accept as a parameter and what it's going to return. In both cases, it's going to be an array of numbers. So with that in mind, we should be able to console log the result or the return of the function. So if I called insertion sort and passed in the inserted array above, the console should have logged into it the array in sorted order, which will be 1, 2, 3, 4, 5, 6, 7, 8. Now that we have our function stubbed out, what's going to be really helpful to understand what we're going to be implementing is a visual of what an insertion sort looks like. Imagine that we have an unsorted deck of cards, and so we draw from the deck of cards one at a time, the drawn card being the card with the red border, and we add it to our hand being cards with a black border. As we add the card to our hand, though, we ensure that we place it in order with regards to the other cards in our hand. And we do this by iterating through each card in our hand and inserting the newly drawn card before the card that is less than or equal to it. So let's get back into our insertion sort function. And we're going to implement the logic to actually sort the unsorted array, and we're going to do this with a while loop. So the logic is going to execute so long as the length of the unsorted array is greater than 0. Now this might seem like it's going to go on forever, but we actually will be removing an element from the array one at a time, decreasing the length of the unsorted array. And so that element that we remove, that's going to be like the number or card that we're drawing from the deck. So we'll call that unsorted number, and we'll draw that element by calling the pop method from the array. And what pop does is it returns the last element from an array while also removing it. So now that we have our unsorted number, or the number or card we're drawing from the deck, we want to find where in our sorted array we want to insert it, or where in our hand we want to place it. And we're going to do this by writing a for loop where we set I equal to 0, and we're going to run the for loop so long as I is less than or equal to the sorted array's length. That way we're just iterating through each number or card in our hand or array. The first condition we're going to check for is if we've reached the end of the sorted array, or if we're at the end of our hand, because if we've reached the end of the hand, then chances are the number or the unsorted number here is the largest number thus far, and so we'll just add it to the end of the array. And so on our sorted array object, we'll call the method called push, and push will just allow us to append a number to the end of the array. Now, because we've increased the size of the sorted array, this loop will kind of continue and continue until we run out of memory. So I'm calling a break to end the for loop, and then the while loop will start to continue. The next condition we're going to check for is if the unsorted number or the card that we've drawn is less than or equal to whatever card or number is in the I index of our hand or our sorted array. If the unsorted number is less than or equal to whatever number belongs in that index, we've discovered where in our sorted array we want to actually add the unsorted number. And so we'll add it to the sorted array by calling the splice method. Now we're going to pass in I, which is the index we want to insert into 0, and the unsorted number. Looking at splice, we can see that the first argument is where we're going to be adding or removing elements to the array. The second argument is how many elements we want to delete. In this case, we don't want to delete anything. We just want to add stuff. And so the last argument is the element that we're actually adding to the array. And with that in mind, we found where we need to insert the card. So we can call break again because there's no need to continue executing the for loop. And in reality, this is pretty much everything we need in order to implement the insertion sort. It's fairly straightforward, and at the end of the while loop, we return this sorted array. That way, let's take a look at line 1. We have our unsorted array as 653187224. Well, we can return that as 1234567 8. So we're actually going to test that by running the code in this file. So we'll just run node index.js, hit enter, and what we should see logged is the sorted array 1, 2, 3, 4 here, and then 5, 6, 7, 8. I hope that you guys found this video explaining how an insertion sort works and then actually implementing it in JavaScript useful. Until next time, you can find me anywhere on the web at Michael Salati. So, until next time, see ya.